Hi, this is going to be talk about very tedious problem that actually I found solution last week. So there's a happy end to the story. Scheduled messaging using Redis, Postgres, RMQ, and AMQ, not necessarily in this order. We're going to go through it in the order that I actually try to resolve the particular business problem. This is like logical progression when you actually try to create a scheduled queue. So my name is Bart and I'm a software engineer at a company called Bisbee. If you want to look the source files now for this presentation, there is the link if somebody is on his PC. We will be doing some small code stuff here as well, so you'll be able to see how it works. So the business case is very simple yet very annoying. You have a PropTech business, so somebody enters a tenancy agreement, and suddenly in 9 months you need to revisit his contract, you need to send notifications, you need to send a cleaning group. Like, there is a lot of stuff happening, but it's not immediate. So I tried, of course, first connect to the queuing system that I was using on every day, so it would be RMQ, and we'll get to that in a second, but found out that is not as simple as you might think it is. It should be in 2018. And it's actually quite hilarious what's the state of the technology in this manner. So what is a scheduled message in this use case? What we have to do? So a piece of information that we can put into action arbitrary number of time. We don't want to do cron tabs. We don't want to every day to see if this is the time where we need to send a cleaning team notification. We would like probably publish consume behaviors to avoid pullers. Respect the order, but not in terms of FIFO, respect the order in terms of the chronology, like when we set the messages in. And probably at least quality of service 1, so we know where we actually took thing out of queue. There's literally you see QoS 0, 1, and 2, and this refers basically to how the acknowledgement is handled, with QoS 0 being basically no acknowledgement, QoS being 1, being server saying, hey, I've seen this process, we can take this queue out, and QoS2 being like at least 4 messages between the server and the client. So to get to the queuing, we need to think how we used to do architecture previously. So we started with client server, right? It's like the oldest story in the world. And then somebody was smart enough to say, hey, we can do Ajax, and we started doing short polling and stuff like this. So you remember first time Facebook was on and this new chat and doing all these nice things and basically work at the time at the scales, but as time progressed, the scales just become unbearable to do stuff like this. And then the third thing, long polling, who just send a request and wait God how knows long to get request back. Yeah, and then we again kind of rediscovered sockets, and then we can do this in the browser. So we can send stuff in, send stuff out, costs only 1 HTTP frame, and then we can broadcast stuff, and it's like, whoa, groundbreaking, right? Back again, we are sending messages on the sockets. And straight after that, we went into microservices, and we went there usually with like idea that, yeah, let's do this in REST. Let's do this in CRUD, let's do 11 waterfalls calls, and let's hope something not break, because if it breaks, you don't know where you are. I mean, you know where you are, but you're retrying the same request, basically not ever clearing your memory and just using your resources. That's the very smart way to do. So logical progression from this was to introduce the idea of a queue, which would be separate service that basically you would take your message in, and then when somebody wants to read it, take this message out. Persist, failover, load balance, all of this stuff that we previously have to think about it when designing architecture kind of went away. What went away also was, or actually changed a bit of paradigm, was the way we think about async. Like, we in JavaScript, we're actually quite good in async, like the way thinking about parallel, not ideally because we're always usually on one thread. Hands up if somebody's doing here like a parallel workers in Node. No, nobody's doing parallel processing, cool. So we are quite good at it to a certain degree. Like if you come to to asking from different languages, it's much harder. But what happened here is it actually have another dimension, because at this point there is no even loop chronology. You don't know what's happening in other services. You need to think about your architecture a bit differently. And so what you need for, as I said, for the simplest queuing system, some network implementation, so the way to actually speak with a server, some way of storing the messages, ordering them, routing. And the next progression in those systems was actually creating exchanges, which actually be the routing part. So you can offload the queue in the time and manner that you think is alright, and basically do everything you want with it without actually having to put too much thought on how it works in a broader sense. Out-of-the-box solution for things that is actually quite complex. So here be dragons. We are approaching the first set of problems, which is try to put the DEM notification in few seconds instead of now. RabbitMQ, one I think the most popular client still. If you check the NPM, it has the library, the AMQ per lib has 600,000 downloads every week, something like this. Not something like jQuery that has 4 million, but getting there. Basically quite solid piece of software and quite reliable, but completely bad for this case. And I don't know, I tried talking with them and they think their architecture is perfect, and I'll show you why in a second, why it's not. So there are two ways to basically do this. There is a dead letter exchange. So what exchanges are, as I told you, is basically like a extra abstraction over the queuing itself, over routing. And what dead letter exchange is means in our case will be where message times out on one of the queues, it's automatically put to the other. And this is basically the first way that people for RabbitMQ actually advise you to do this. And the other was a plugin that basically has his own implementation of some indexing. And when I was actually reading at the time the information about it, you would see that some people were complaining, for example, when they would purge the queue, the messages were still appearing. So it's not really a nice thing in such a system. You would expect it to kind of work out of the box. Yeah, we can go to the first demo now with the RabbitMQ. Cool. I'm using TypeScript for the last 4 years. Helpful, limits errors. It's the types, of course, are only on level of transpilation, so the checks is there. It's not mutable, but if you go with protobuf afterwards, with connection with TypeScript, you can get actually mutable structures. So the case, we're gonna change it a bit. So let's comment this stuff out for now, because this is actually the error case. And let's go with something really simple, right? So I'm scheduling one message, maybe before even we go there. So what's happening here? I have derived classes with publisher and subscribers. This is like a small wrappers over the RMQ really that allows you to just put to multiple queues. We can view them. Basically, get config in, connect, create a channel, assert a queue. We'll get to assert what it means in a second. Basically, just a bit of infrastructure for you to be able to basically do this instead of having to worry how it works. So why there is this conditional attach and attach exchange here? Idea is that basically you're recreating. If somebody goes to RMQ and just flashes it and goes to your queue and purges it and it disappears, the idea is that you create from the code. Also, if there's another service using the same queue, if you give it a different set of settings, it will alarm somebody, it will crash. Will say, hi, this queue was supposed to be durable, but it's not. And if you look at the test one, which are the queues, so you see it's basically saying it's work exchange that is described below. and to use routing key 1 if something goes wrong, and the max priority is 10. Then you have the test 2, and then you have the actual exchange that says basically the routing key 1 is test 2. So without further ado, let's go with this. So we sent a queue. I sent some messages before, so they just came in. So after more or less 10 seconds, the message should appear in the console that, some other stuff. It's not safe, that's why. Okay, restarting. I've been just testing this, because those libraries are basically extracted from some of my projects, from different places. I just had to make sure it works. So, yeah, and this basically was the message that we described here. So it took 10 seconds for it. If you would look at the, not here. If you would look at at what's happening in the RabbitMQ overview, might not pick it because it's just 10 seconds. Exchanges queues. If you look at the queue, let's restart it. Come on. It's already taken down. But basically, this appears here, and you can see that this is moving from one queue to another, basically taking it from the top of the stack if it's expired, moving to the other, right? So seems like it works till now. Now we do something more fancy. So we send those messages like this, which first is, how do you expect they should come back? Is the question. The first one delay is 10 seconds, the other delay is 8, the third one 4, and the last one is 1. What do you expect what for you should happen if you do stuff like this? Well, you kind of have your answer, but you need to kind of look and focus what's happening. So I just restarted it. It sent 3 messages. First one is supposed to time out after 1 second. But nothing is happening. And suddenly they all come. They all come in a completely different order that you expect them to come. And why is that? RMQ, the way RMQ basically implements the queues, if the item is not touched from the top of the stack, from the last item in the queue, it will not do anything with it. So when we first send the item that has to wait 10 seconds, everything behind basically is waiting. Kinda can't go with the business case like this, because if you send something half a year in advance, it will just be stuck there forever and you won't ever do anything with it. Sucks, right? You can play with priorities. I was going to, but I don't think I will have time. So priorities in RMQ. When you look at what priorities are and how they are described in the RMQ documentation, it looks like a leaflet of a really bad drug. There is so many things not to do and why not to do that you basically feel like you shouldn't even touch it. There's limitation of 256 priority levels. Every priority kind of creates its internal queue, and there is memory limitation, and the thing goes on and on and on. And to tell the truth, it still doesn't solve the fact that if you're stuck on the first element, you're just basically going to be stuck there until it pops out. So RMQ is not a tool for the job, and at the time when I was checking everything, actually there wasn't anything good, and this was kind of mind-boggling that you use Google and Stack Overflow and it's just go to Kafka and do your own consumer and stuff like this, but it's guys, this is a very simple problem. And you would watch actually Google and be the guys saying, oh yeah, we do basically this Postgres here and there, and it's it's 2018, we shouldn't be doing stuff like this manually. It's just ridiculous. So this was me at the time. So, but what we get with RMQ, because this is the point, we avoiding the cron, right? It's a queue. We have publish consume, completely break down if you do the order. What is interesting, if the delays are in the same amount of time, it of course will work. But as soon as you have a different amount of times on the queue, completely breaks down. Confirm works, prefetch works. Prefetch means how many you're telling to the broker how many you want items received from the queue at the same time, so you can process 10 in your one worker. Multiple consumers, avoiding polling, of course. Can store data persistently. RMQ allows you to like 2 GB messages if you're crazy enough to do this. Out of the bulk replicas, priority sucks. Indexing methods, well, you kind of goes with priorities really. So yeah, this, as I said, this is like the biggest limitation of it. It's like the way it's internally implemented, and it's unlikely to change. So what do software engineers do when he just finds a problem that nobody done this, right? It's like thinks, oh, let's go with Redis. So anybody use Redis? Most of the guys. Nice piece of software, in-store key value with persistence, replica sets, features. What I used for this is Z-range and Z-rem. So basically we have indexed range of objects where the int that is a timestamp is basically deciding on the order, and then Z-rem to actually do the acknowledge to remove stuff from this. If you want to see the demo, it's there. We will just prove that it works. So if you look at the Redis, basically the same stuff, 20 seconds delayed, 10 seconds delay. First message that came, message 2, so the message that was 10 seconds, the other message will come, the message with 20 seconds. Nice, right? So basically we solved the problem. Well, not really. Nothing is that simple. So what happens is, let's start to think about it in terms of our business goal. Yeah, we're avoiding cron tab. That's fine, right? We do publish consume, more or less. We are emulating this. We respect order, and it's not FIFO because we have the arbitrary index. We can emulate the QS. We can email with the prefetch. In the working example that you have there, it's only working for one consumer because I didn't bother to do transactions and stuff. For business case like this, if you have one consumer that offloads everything and ships it to appropriate queues, it probably will be enough, but you can do this. We cannot avoid polling. It's the nature of it that you can't get around polling. Can store data persistently for a long time? Well, not really. Everything is memory. So even if you persist something, the Redis crashes, loads up, everything goes to memory. It might not be a problem if you're like storing IDs, but if you start to store objects, suddenly you're running out of RAM. And especially if there's something else working on the same instance, it's basically you can kill yourself with this. You have out-of-the-box replicas and no way to do priorities, and indexing really works really nicely. As I said, there is a very good alternative to it. There is a project called RDB. I think Netflix guys bought them and uses them through like some of their solutions. It's basically Redis protocol, but the store is all on the drive. So you kind of eliminate the problem of in-memory. And this kind of allows you to work, but you need to host it, and then you need to take care of it, and we're lazy, 2018. So, and as I said, multiple consumers, you need to basically write your own transactions and logs. And we're not avoiding polling. So, okay, not Redis, Postgres. Another tool. Anybody use Postgres? Yes, this is what I like. So, an unpackable reputation, I would say, if it goes to databases. And example. The same example. Do you want to see consumers and publishers, more or less, what was used to emulate this? Are you interested? Yes, no? All right. So, so let's go with publisher. Standard thing connects to the Postgres. Then publish method that kind of creates like this whole structure previously. It's all emulated RMQ, so they all kind of emulate multiple channels to which you can send. Creating that the table that actually holds this. It's just JSONB and time index that is big int. We're not using IDs to don't create any holes and allow Postgres to actually efficiently process the deletes and stuff like this. And then you can forget about this if. This is about unique. Redis has this thing that you can set that, going back to Redis for a second, that you can have unique entries in the queue, which means if you ever want to replace the information and put it to like a different timestamp, it's doable. So because this was the next step, I kind of do the same, but it's not necessary. So very simple insert into your message and delay of time. And the consumer basically that is polling and executing select on IDs where time index, right? Nothing more simpler than that. On acknowledge, what we do is delete, which is that. Now, what is nice here with Postgres, we're actually using the types that are provided to the PG library to say what item is. So if you like go to query results, see what's the interface. Well, this is not too much, but you will see that there is like rows and other stuff. Makes hard to make errors when you're writing something. So further ado, this is it. Cool. PG. As you expect, the first message would appear with message 2. Right, it works, right? Well, avoiding cron, we have publish, order, we do confirm, find, prefetch, multiple consumers, we need to do our own transaction implementation. Can store data persistently for a long time, very good. Large messages, whatever message size, we can go with it. Out of the box replicas, cool. Indexing, superb. Priorities, not there, but if you add extra field there and then you sort by it, works. What we're still missing here is polling. We're still poll it. We can't get around it really because effectively what we're doing here is we're actually creating a broker, which is we're creating RMQ or Rabbit or ZeroMQ. This is what those two solutions were basically create your own broker that does this one simple thing. But we don't want to be in the business of creating brokers. We would rather just utilize it, whatever is there. And here enters the active MQ, which is, you can get it on Amazon MQ. It's like a few other hosting services. A very nice tool. To tell the truth, I discovered this last week, and I literally tested this last week when I was just doing last bits and pieces for the presentation. So what they give you, the AMQ P10 protocol, this will not work with RMQ clients, the Rabbit clients, because RMQ is using 091 and they are inherently different. So there is this library that we use, which is called RIA, and seems quite promising. Year ago with Total, it was bad, like a year ago when it actually was released on the market. And the main advice people were giving you, if you're using Java, go ActiveMQ. If you don't use Java, just do something else. But during this year, a lot of changes. So AMQP that we used, MQTT, Stomp, OpenWire, this is all like tools to connect to this queue and basically gives you freedom of how you interact with it. Also exposes different functionalities in the queuing system itself. So we need to go back to the code because this is most interesting. But I need to create env. And this I will find window. If we go here, db. Yeah, 5 minutes, cool. We'll do this very fast. Where was this? Utils. Source AMQ example. Yeah. Damn it. very important. So let's go to the last part, which is this stuff. Basically, there from version 5.4, there is something which is called scheduler plugin that allows you to send arbitrary fields that actually has the delay like you would expect to have, and this can be whatever big int that you can think of. So wow basically works how is it supposed to work. TS node and this is AMQ. Didn't save the end file. Right, so what we did here was send buffer, send object, and send text. And in a second, like when all the message come back, I'll just put it here in the screen. Just copy it over. And this is what actually appeared in the console after they come back and they were read by the consumer. The first one that came back was the message 4 that has 5 seconds delay. That was a string, and then came back the message. Which one was it? And then they came back in the order that they were received, so from 1 to 3. The first one was buffer, the other was object. Fun thing, I don't have time now. I was going to show you. You can hook protobuf to it in a matter of 10 minutes and basically send protobuf messages like this. There is no type conversion between publisher or consumer. You basically do protobuf encode and pass it to the RIA, and they will do the whole job for you. Like, this is really cool stuff. So we got the demo, nailed it. Basically what we needed. The Amazon one used the KahaDB as the store, quite performant. Questions, which I think we don't do, and thank you.